journey began with testing all the main components that would power the robot. I started with the Arduino microcontroller, which serves as the brain of the system. Then I tested the DC motors that would drive the wheels, ensuring they responded correctly to control signals. Next came the sensors, including line-following sensors to keep the robot on track, and obstacle avoidance sensors to help it navigate around objects safely. This early stage was crucial to make sure each part worked properly before moving on to assembly. Once the components were tested, I connected the motor driver to the Arduino, which acts like the robot's muscle controller. I then fixed the Arduino neatly at the bottom of the chassis, making sure it fit perfectly in its designated spot. The motors were connected to the motor driver, giving the robot the ability to move smoothly in any direction. This was the foundation on which the rest of the build would be constructed. With the electronics in place, I moved on to building the rest of the chassis. This included assembling the head of the robot and other body sections, ensuring that each piece was sturdy, balanced, and positioned for easy access during maintenance. The design had to be both functional and aesthetically appealing. Before wiring everything permanently, I reviewed my circuit diagram in detail. To verify my design, I used an online circuit simulation platform. Here, I connected virtual versions of all my components, the obstacle avoidance sensor, line following sensor, servo motors, and DC motors, and ran tests to make sure the logic worked perfectly. This step saved a lot of troubleshooting time later on, because I could identify and fix problems before touching the physical hardware. After confirming the simulation results, I began assembling the body and head onto the chassis for real-world testing. I then moved into the coding phase, programming the Arduino to process sensor data, control movement, and react intelligently to its environment. Every line of code was written to ensure smooth navigation, reliable obstacle avoidance, and precise line following. Once the logic and movement were fine-tuned, I completed the full body assembly. I also worked on the final visual design, giving the robot a neat, attractive appearance that would fit well in a hotel or restaurant setting. At this point, the hardware was complete, and the robot was ready to serve. To make the robot more interactive and useful, I developed a web-based ordering system. Here's how it works. When customers arrive at the restaurant or hotel, they can scan a QR code displayed on their table or in their room. This takes them directly to the ordering website, where they can choose their meals or drinks and submit the order. The kitchen staff receive the request, prepare the order, and then place it on the robot. The robot, connected to the website via Bluetooth, knows exactly which table or room to deliver to.
Alex B navigating using floor sensors, avoiding obstacles and stopping precisely at a particular table. Powered by real-time sensors and AI navigation, Alex B redefines smart services, autonomous, efficient, and built for the future of hospitality. Guests emerged impressed by the seamless and contactless service. Alex B, the future itself. Designed for precision, built for efficiency, and driven by intelligence. It is not just a robot, it is a revolution on wheels.